Okay, I'm going to video what I consider is possibly one of the most important experiments in terms of what we've done with what we learned from the outcome of this experiment. Quite simply, I'll kind of talk you through it. Power supply, the negative terminal, electrons are going to leave here, so this is just acting like a battery. Negatives are going to get pushed out of this terminal through the black wire. They come up here and into this copper wire. Down the copper wire. Here's where the important part is. The copper wire is going to pass through the north and south poles of this permanent magnet. So there's going to be electrons going to the left in between the north and the south. And then to complete the circuit, they go up, enter the red wire, and go back to the power supply. I'll turn it on so you can see this super awesome observation for yourself. And then in class or later in this note, we'll talk about why it's so important. Here we go. Not so dramatic. I'll try and get a different angle on that so you can see what happened. So it's kind of looking at it from above. It's wobbling just because it's such a light wire. Okay, going to turn on the power. 3, 2, 1. That's with the power on. Shutting off the power. It falls back. The outcome is, we'll talk why it's so crazy. We'll talk lots about this. But when there's a current flowing through this wire that's in between the magnetic field, the nature of the current being in a magnetic field produces a force on the wire. Then engineers can take over and do lots of cool stuff with that.